It's excellent to be here in this context, given all of what was just said about my starting here with my research, and with all of you who braved all this terrible weather to be here on a Monday night. You must have really genuine interest. So, I will move quickly, and you can expect me to work to answer these questions that you see on the first slide, which I won't read because if you're like me, you go to a lot of presentations and it could drive you crazy if someone just reads their slides. This is what I will be working on. To begin with, an example from where I live now in the Netherlands. This is something I'm sure you all know what that is, that object. But what you might not know is that in the last 2 years or so, the price of commercial drones has precipitously dropped, such that you can get a decent one for like a few $100s. And this precipitates some really interesting security concerns in places where you can imagine if companies are handling toxic materials, or there's machinery that's sensitive that is working, like imagine at an airport when airplanes are landing and taking off, drones might be able to interfere with them. So experts have looked at different possibilities of how to neutralize them, lasers, throwing nets at them, even exotic technologies like using electromagnetic pulses to disable them. But this firm called Guard from Above, based in The Hague, has presented a more bio-based solution by training birds of prey to regard drones as food. And over the course of a year, they can do this with hawks and eagles. I've interviewed the people who work there, and they're quite nice and helpful, but they're sworn to secrecy for security reasons, so it's unclear where these birds are deployed. But one place that I know that they are is in Schiphol Airport in Amsterdam. And how this works from the point of view of the drone encroaching into a place where it belongs not. And there's something really satisfying about seeing technology and biology meet in this way. And it's also reflective of what you see also at an airport when there are dogs working that sniff for drugs or explosives, and you realize that despite our most advanced technology, the engineering or the sort of design solution that's within that animal's nose bests it all. So that is just one of 72 examples that I profile in this new edition of the book Biodesign. And as I define it, this is the approach of trying to integrate or harness biological processes for design. This is a step beyond what is often talked about as biomimicry, or just observing what's in nature and trying to copy that as an engineering solution. The book originally was published in 2012, and the new edition, as Molly mentioned, is available as of August. There's some specifications, and you don't need to read all this stuff. Trust me, it's nice things about the book. And that gave me this opportunity to realize or materialize some of the contents in the book as exhibitions, to invite some of the people that I wrote about to actually bring their work together and present it to the public. One of the first opportunities to do that was in Rotterdam at the Nieuwe Instituut in 2013, for which we gathered 57 different projects. These are some installation shots. Then subsequently in Bursa, Turkey. And then most recently at the Rhode Island School of Design, where I was really privileged to work with a small team of people who were identified as biodesigners, bioartists, and who were also involved at RISD in some way in the teaching and running departments like the what's called co-works. And this was this combination of experiences of having worked on these exhibitions has provided me with some of these reflections that I'll share with you about sort of the opportunities and problems of such a design approach. And this is just a quick look at the installation at the Rhode Island School of Design, which was quite beautiful. And so I mentioned biomimicry before, and that's the topic of or subject of this book, which is published first in 1997. It's still a wonderful read, and the I think the intentions behind it and the arguments that it makes are still quite valid. Unfortunately, what has happened in the popular imagination and the popular press is biomimicry as a term has really been attenuated from, its true meaning has been attenuated by its overuse. I mean, anything like, this fish on my shirt, like, is that biomimicry? Arguably it is, but it's not very useful, except it looks kind of nice. And then, Cradle to Cradle, which I imagine many of you are familiar with. It's probably in its 9th or 10th edition at this point. And this book makes the case for, at the very macro level, to try to reform building and manufacturing practices so that they more resemble what happens in ecosystems, in which waste is eliminated and anything that goes into one process can either safely enter another one or be put back into the environment. I think the first edition of this book came out in 2003, and I remember reading it. It was like just the right time for me to, or at the height of my optimism, and I was convinced that this case was being made so strongly that surely this is going to blow up the design world, and practices like these will be adopted. And of course, they weren't. And so when I was in this program, I was curious about solutions in achieving sustainability, or as I came to describe it, greater ecological performance. Please come sit down. Welcome. I found these examples, and at the same time, as Molly hinted at, I was learning how to brew beer and make bread, which involves this close association with and partnering with yeasts, trying to understand them better. And so the combination of those two experiences kind of came together, and when you start to learn about yeast and you start to brew your own beer and wine, you learn eventually that the yeast that we use is been cultivated for a long time, and of course it's incredibly useful. But all of even in today, the advance of science where it is, what we know about yeast, or the varieties of yeast that have been categorized and sequenced, represent only about 2% of what's estimated to be out in the world. So if only that little bit is known about such a useful organism, you think, what else could be out there? Clearly, or almost certainly, the biosphere is bursting with opportunities for mutually beneficial partnership. And that seemed to be how some of these designers that I found that were doing these sometimes speculative and radical experiments with integrating biology with design, what they were up to. So also foundational, the book and exhibition, Design in the Elastic Mind, in 2008, that was curated by Paolo Antonelli. The essays in particular in this book were really formative for me in trying to come up with an idea of what biodesign could be. And then to underline the urgency of why such reform in design practice is needed, this book was particularly important to me. And among other things, besides its reportage, this book very persuasively argues for creating systems of incentives and disincentives that would make approaches like biodesign economically feasible. Things like a punishingly high carbon tax, or subsidies for manufacturing and building practices that can measurably show to support biodiversity or the resiliency of an ecosystem. If such reforms could be made, I'm convinced that many of these biodesign projects which get stuck in the prototype stage could actually advance. And at the core of this, I think that what this book argues for, and what I believe is at the a very important component of biodesign, is an attempt to unlink economic growth from the destruction of the environment. I think that's really important, so I'll repeat it. It's to unlink economic growth from the degradation of the environment. And how to do that, as I've hinted at, I think the economic approach is going to be the most effective, and in light of the climate crisis, I don't really see a quicker or more effective way. So this means creating incentives and disincentives, but also assigning value to some of the biodiversity services that environments create. And this is some of the ways in which that could be described. And then how this is demonstrated through design. A couple of examples I'll go through. This footbridge near Lake Constance in Germany is the work of Ferdinand Ludwig and some of his collaborators from the University of Stuttgart and now the Technical University of Munich. And it's not meant to propose how all architecture should be in the future, but rather show that in this very beautiful and interesting way, the built and the natural environments can be woven together. And in a project like this, what's most appealing to me is the alignment that occurs between the interests of the environment and the interests of the people involved. So the architect, the user, and the developer or owner of this space has a vested interest in maintaining clean air, soil, and water. Otherwise, architecture like this can't work. It also is not just a footbridge, but a foothold for numerous species, from insects and birds to the organisms, like microorganisms in the ground. This team has done a number of projects. Many are very beautiful and funny and worth attention. But of course, working with biology in this way to make functional architecture is not entirely new. These root bridges that you see are from northeastern India, and some of them are 500 to 600 years old. They're grown via coaxing the development of the roots of rubber trees, and this is a kind of necessary architectural technology in a place where it's one of the wettest microclimates on Earth. They see thousands of centimeters of rain every year, so what looks like placid water here can at any moment turn into a raging river. And architecture like this is such that the makers of it don't really have control of the final form, of course, because biology has ideas of its own. And then when you use it, imagine walking across something like this and the soil or leaves on your shoes are left behind. They can become part of the actual architecture because these are living root systems and they can absorb some of that matter. Then flipping to more contemporary examples, the Bosco Verticale, or vertical forest, by the studio of Stefano Borri. This set of buildings was constructed in Milan, taking advantage of the small footprint of a skyscraper, of course, and its height to introduce on all its different levels more than 900 trees and shrubs. So kind of like the footbridge, giving a place where biology can thrive and flourish, not to mention it's beautiful. Admittedly, this is a very expensive type of architecture to erect, but it's becoming less expensive. I've learned via the popularity of this project, which was completed a few years ago, has led to several other commissions of buildings of its kind. But how far can we take this? Can we live someday in what look like hobbit holes that are grown from trees over the course of 10 or 15 years? This vision is proposed by Terraform One, and interestingly, it accompanied a business plan that laid out what kind of investments would be necessary and what returns might be, what kind of permits would be needed. And I'll say that before I got into the writing and curating racket, I worked in product development, licensing, marketing, business, and so I saw a good many business plans, and I have a pretty good bullshit detector, but this was really feasible in some ways. But of course, the risk of trying to grow something and expect it to be a functional house is more than developers are willing to take. So there's that economic component of this, which is really key, but also there's a psychological threshold that I think a lot of us have to cross before we would deem this kind of architecture acceptable. And part of that problem comes from work like this terrible structure by Mies van der Rohe, the Seagram building, that many have called the epitome of mid-century modern architecture, completed in 1958. It's clean rectilinear forms really set the tone or the standard for how a lot of architecture would be practiced in New York and elsewhere. It's machine aesthetic, captured here pretty well by Tom Wolfe in his book, which if you haven't seen or if you haven't read, it's short and it's very funny, and it's a send-up of America's embrace of European modernism. So one of the problems I have with the Seagram building is that it is one of the most energy inefficient buildings in the city. According to a study that was done a few years ago, it ranked very near the bottom, in part because so many of the design features that Mies had to insist on didn't take into account any of these sort of contemporary considerations for conserving energy or retaining heat. And this is the supposedly machine aesthetic, the ornamental facade in bronze. And I think it's underappreciated how some of the origins of the embrace of the mid-century modern aesthetic, the machine aesthetic, is rooted in our experience, our human experience of sickness, of suffering and death at the hands of biology. These are people sick with the Spanish flu, bedded at the Brooklyn Navy Yard in 1918. That was an epidemic that killed 50 million people, or about 3% of the world's population. And since that time, these sort of pandemics have largely been contained. Of course, they're not gone, but the effect, you can just sort of glance at this and have a sense of how much less of an impact they have. This is all recent history, okay? The germ theory of disease only became sort of widely accepted in the early 20th century, and then it took a few more decades for us to have reliable sources of antibiotics. So it's no wonder that when we think about microbes, we conflate them with pathogens all the time, or that we over-sanitize our spaces, that we overuse cleaning products, which, as we've learned, actually creates more dangerous pathogens because you kill all the neutral and beneficial stuff. And I think this is the sort of underrepresented thread of explaining why the mid-century modern aesthetic took hold as well as it did. But this is all beginning to change, thanks in part to research in the life sciences. For example, the discoveries that are being made about the human microbiome, that refers to the trillions of organisms that live inside and on our bodies, helps us understand ourselves differently as this kind of superorganism that relies on all this other non-human life. In this issue of The Economist, it's argued pretty persuasively that these populations constitute another human organ, that they're actually that important when you add up all of the functions that they either assist with or do independently, whether it's helping digestion, the immune system, or your sense of well-being. And it turns out, as so the human goes, the built environment does as well. There's quite a growing amount of research that's being done on how the indoor spaces that we live in also contain their own microbiomes. There's research being done at this organization that's based at the University of Oregon at Eugene, and what they've been doing is sampling the insides of spaces, like it could be this room here, a place where classrooms or class meetings are held, or shops, or studios, bedrooms, hospitals in particular. And the idea or the hope is that by learning what likes to live where, we might be able to correlate design features or architectural approaches with a probiotic or a healthy indoor microbiome. This becomes particularly important in environments like hospitals. And their early findings, which are quite interesting, this is just a visualization to give a sense of how abundant all this life is. But their early findings suggest that under certain conditions of climate and temperature in hospitals, which use power-hungry mechanical ventilation systems, that you can be better off just opening the window. So this might make you want to take a shower, or it be an inspiration, I'm not sure. But to get a deeper sense of what the potential might be for using microorganisms, let's say, in design, is illustrated to me quite well in the history of the material concrete, which is something I wrote about in my thesis written here at SVA. And I'll kind of touch on this as briefly as I can. So the history of concrete, really picks up and takes off in the time of the Roman architectural revolution, and was behind the construction of numerous typologies that became important or were important to the empire, from aqueducts and roads to bathhouses, bridges, structures like this one, the Pantheon, which still has the largest unsupported poured concrete dome in the world. But of course, the Roman Empire disintegrated. This is a great depiction of the course of empire by Thomas Cole from the 19th century. And during this period, or right after the fall of Rome, the formula for making concrete was lost for 13 centuries. And it wasn't rediscovered and reapplied until the dawn of the Industrial Revolution in 18th century Great Britain. And I don't think that's a coincidence. I think the pressures and the priorities that were being set by the Industrial Revolution sort of demanded performance of architecture and demanded performance of engineering solutions that made it somewhat inevitable that we would use concrete again. And then it was just 100 years later that Francois Coinet and some others discovered how to make concrete work even better by reinforcing it with rebar, this giving it tensile strength to complement its compression strength. And that allowed us to make ever taller buildings and works like this, the Aqueduct de Lavande in Paris. Remember, this is the 19th century where the pressures of urbanization and the competition by colonialism were super intense. And now, 200 years after that, there's a new kind of concrete that's being tested and experimented with called bioconcrete. This is being researched in a few places, but the one that I know most about is at the Technology University in Delft in the Netherlands. And this kind of concrete looks like the ordinary sort, but within it is embedded nutrients and populations of microbes that are specialized. They're called extremophiles, and they're able to endure very, very harsh environments like the inside of concrete. And some of them exhibit these very special properties, like the particular ones used in this kind of experimental concrete will secrete limestone when they're exposed to the elements. So if they're embedded, like in the sample on the right, and a crack forms, they will actually seal it if the crack is small enough and under the right conditions. So it gives the material the property of self-healing by way of these microbes. Now this becomes important when you step back and look at the kind of macro impact of concrete. It's one of the most produced commodities in the world. We make billions of it a year, and roughly for every ton of it you make, you emit a ton of carbon. So if something like this could be widely adopted, it could make a big impact by way of extending the service life of concrete, even if it's just a few years. And I think it's significant in that it's a sign of how our priorities are changing. Likewise, the active phytoremediation system that's being studied at RPI in New York with the help of Skidmore, Owings, and Merrill is a modular system that takes advantage of air plants that have naturally growing on them organisms that can safely digest volatile organic compounds. This, similar to what was being mentioned before about the indoor microbiome, has a way to potentially replace mechanical ventilation systems as they clean the air, and they look quite a lot nicer than fans. And then more on the industrial scale, this moss table by Carlos Peralta and Alex Driver is an example of an experiment using biophotovoltaics that takes advantage of the relationship between mosses and their photosynthesis and the soil microbes that like to digest those compounds. They, in their own metabolism, release a small trickle of electrons which can be captured and strung along with this carbon fiber to create a small current in a very recognizable industrial design form. Now this is, a lot of people will say, and particularly scientists, that they don't be careful and qualify this by mentioning to people that this is not, at the moment, a viable solution for replacing energy sources. But it is, I think, like some of the other projects that you'll see in the book, it's a step towards getting people to be a little bit more comfortable with organisms being interwoven in their everyday lives and into design. For every project like this, I think something like bioconcrete becomes more acceptable, less scary. I've, over the course of many exhibitions, given people tours, and almost always we pass by the bioconcrete sample, and someone has to ask, like, but what happens when you touch it? What happens when it starts to eat the building or it gets loose? And they have these visions of, like, it's got to be pathogenic. And I think it again goes back to our being unhealthily hardwired to be afraid of all these things. And then looking to the future of synthetic biology, this prototype of a t-shirt was made by Modern Meadow, which is a company based in New Jersey. And they have found a way to alter yeast cells so that they produce collagen, which is the main ingredient in what becomes leather, or what holds our skin together. And what we normally harvest from steers and cows and other creatures. Well, by making it in a lab by way of yeasts, the energy usage to make this leather is so much less, and the time that you have to wait and the kind of wastes that are created are all very, very much limited when compared to traditional methods. And this prototype was commissioned by the Museum of Modern Art, and this was included in the Items Is Fashion Modern show, and has since become part of the permanent collection. A notable feature of this kind of leather, which is biofabricated, is that it exists for a time in a liquid format, which allows you to spread it and sort of arrange it in ways that are sort of breaking away from the limitations that normally come with using the hide of an animal. And then another new project that's featured in the new edition of Biodesign is this work, a series of works by Diana Scherer, a German artist who has figured out how to domesticate grasses and guide the growth of their root systems into these sort of molds that she creates in patterns that resemble Art Nouveau and its different iterations that existed across Europe and the United States in the 19th century, which themselves were inspired by organic forms. So in this very literal way, it's kind of come full circle that an artist and designer has found a way to grow something that was a mimicry of something that was grown. And at some point, all of this working with non-human life brings with it ethical implications and problems. And this is a topic for a whole nother book and a whole nother presentation, but it's worth stopping and noting that our limitations on what is acceptable and not when it comes to other organisms are really arbitrary. And so most people agree that when it comes to microbes, anything goes, you can kill billions of them, who cares? Rats, it's kind of the same, and other species, but where do we draw the lines, and at what point does a very well-meaning approach to design like biodesign equate to a kind of interspecies slavery? So a lot of empathy and a lot of debate and study really should work into this. And it's worth asking, when you saw the example of the hawks and the eagles at the top of the presentation, well, it seems like a clever idea, but would it still be okay with you if 10% of those animals at work were hurt or killed by way of banging into drones? So to learn more about how biodesign is being practiced and the emerging sort of community around it, I would recommend to anyone to look into the Biodesign Challenge, which is an event, a competition that's hosted by the Museum of Modern Art, and also the Bioart and Design Award, called the BAD Award, that grants quite a generous sum to people who have proposals for art or design that uses biology in an original way. It's based in the Netherlands, but people apply from everywhere. And then just a brief jump into fine art practice by way of this book that I wrote, which profiles 60 different artists or artist collectives that are doing work that uses biology literally in a very original way, or can be said to be, their work is reflecting on how our shared notions of what is natural, what's live, and what constitutes an identity are all in flux. They're all shifting as a result of the realization of biotechnologies. Now, whether you're an artist or a designer, or even a journalist or writer looking to dive into these topics, best practices around collaboration are important to be aware of. Helping or just trying to spread this information in part because some of you will be teachers, some of you are designers, and I think this can be quite helpful when thinking about how to work with someone who's a specialist in the sciences. And so I'll show you these two sample requests. These are just short emails. I'll ask you to please skim them. And please, when you've gotten through it, just like nod your head so I know that you're finished. Now, this is a second email asking for essentially the same thing, but try to notice how it's different. Okay. So are both emails perfectly acceptable? Does anyone think the first email is better or more likely to get a response? No. Why is the second one better? Does anybody?
The question at the end. The question at the end. More collaborative.
Well, and
Yeah.
his introduction is like they're aware of the work that they're already doing. He's citing the work of the person that he wants to talk to.
Right. Someone has done their homework and is starting from
More awesome. I'd like to know more about what you do.
Exactly. So with working with non-human organisms, sort of the same applies with human organisms, that empathy and really trying to understand the perspective of the other is essential. There's so many bio projects that I've sort of been privy to that have just not, or advanced slowly or not at all, because people have been missing this consideration. So in conclusion, these are some considerations. And I would just reemphasize the last one on the list about design like this, particularly the speculative sort, being a way to sort of reveal how dysfunctional certain systems are. And then more on collaboration. My publisher would not like me to say this, but I have like this new chapter that's in the new edition that's all about tips for getting started. I have all the contents available for free on this website. So you can go there if you're a student or you're just curious. Now, what follows in the next few minutes amounts to a bit of a public service announcement. In this age where we have to be much more careful about how we consume media, we are bombarded with emotionally potent oversimplifications, and design plays a role in this, and I think needs to play a role in correcting for it. And I think what really ought to emerge is a practice or a sort of discipline around mental and social ergonomics in the similar way that we have physical ergonomics that we consider, like the shape of the spine when you design a chair, your tolerances and your psychological vulnerabilities, because these are being exploited very quickly and effectively by people and by machine learning systems that are feeding us information that's guiding how we think and how we think of each other in ways that's becoming dangerous. The social impact of design, the design of platforms, particularly in the social media landscape, is super problematic. Just a piece of evidence of that can be seen in this map, which shows the results of a survey that was conducted by The Economist recently, and this shows you the difference between the reality and the perception of the percentage of the Muslim population in these different countries. So in Great Britain, people who were asked thought it was 21% on average their population was Muslim, but in fact it's 5%. And so on. As a result, I'm convinced of the sensationalism that surrounds any kind of news that has to do with Muslims in Western Europe. And there are, of course, many other examples of this. This is just a particularly, visible one. And so, okay, the social impact of design is something that is not really understood or appreciated sufficiently. And in my experience, work like biodesign, which prioritizes making better or improving the ecological impact of the built world, in order to try to give them their due, to try to sort of champion those practices, to recognize the best achievements in it, and to bring it to the public in a more meaningful way, I would argue for the creation of a design museum institution that collects such examples, that does not have an iPhone in it, that doesn't rely on a physical collection, and tries to reverse some of the socialization that we have to, for example, when we go to an exhibition, whether it's design or art, we think that we're not supposed to talk and we're not supposed to touch. Our engagement is in these controlled and very limited ways, which for design just makes no sense. And it would be the kind of organization that would have curators that would make considerations like, what is the wage on the production line where that object is made? Or what is the effect of biodiversity on biodiversity of the extraction of materials to make this object? And I think in making this step, it would be necessary to sort of dismiss or step beyond the traditional categorizations of design that we've come to know, and instead just look at really what is the measurable social and ecological impacts of these things in the world, of these interfaces in the world, and by doing that, accelerate practices that prioritize those factors. So if this interests you, I encourage you to talk to me afterwards, or visit this website and sign up. It's an organization in its infancy, so if anyone knows of a donor with $1 million or something, I really would like to meet them. And now some content. This is the last portion that's focused on publishing and what it's like some of you are writers or students, aspiring authors, or maybe you've written books already and you want to compare experiences. I am sort of opening the books here and giving a sense of what it was like for me to go through this process. Some things to keep in mind when editor or commissioning editor is talking with you and you're proposing something, they're almost always thinking that, okay, I'm going to lose money on this. And they're, of course, trying to minimize how much money they lose. So you want to be aware of that, and that any royalty percentage is generally calculated as part of wholesale, which is half of what the retail price is, generally speaking. So in my case, the hours worked included time here, which not only did I not get paid for, but I was paying for by way of student loans. These, of course, are estimates. They're not to the minute, but what you could see is that it's quite a low-paying enterprise, especially at the beginning. And even to give him credit, in the words of my commissioning editor, writing books is one of the shortest routes to poverty. Yeah, it's a little bit longer than habitual drug use, but not very much. But then, in the last 5 years, I've been able to capture some ancillary income by way of exhibitions, by way of freelance writing, some teaching work, which I could have probably done more of, but I was busy with some other things. And now this number, the bottom line number, looks very nice, but it's spread over 5 years. And so it's not really enough to live off of with a family. One has to sort of supplement this all with additional writing projects, or in my case, editing books. So I'd urge anyone who got into this racket to reap the intangibles as well as possible. Recognize that books still, thankfully, carry some weight in terms of having authority that goes with them, and it's really best to exploit that as much as possible. Travel and try to meet people in your community as quickly as possible. And then, of course, there are many different types of books out there. The ones that I've worked on really prioritize breadth instead of depth, which is a source of some frustration. Similar to how one would write a thesis for their master's degree or a PhD, you tend to go deeper in a single subject or a small set of subjects and really thoroughly explore and explain them. But with survey books, you really have to get in and out, and in what I mentioned, 73 different projects and designers, there's almost so much time you can spend with each. It's also a good to point out that you have to be prepared to do a lot of legwork in terms of just securing the rights to use images for your book. That every image that you see in most books, I know in my books, required a signed agreement that you have to traffic and you have to keep track of and hand into your publisher before they will actually print anything. And then some considerations that are, I think, top of mind for commissioning editor. Among these, who is the audience seems to occupy most of their thinking. So being able to articulate exactly what are the different profiles of people that will just must have your book is really important to do. And then, be relentless. In my experience, I had to really push it and, call at odd times and just make sure they, the worst that can happen is they tell you no. And note about in advance, it's often paid in little chunks. So let's say they say $10,000 and you say, oh, that sounds great. But then they only give you, when you sign the contract, $1,500, and then you get $2,000 more 3 months later when you give them half the book, and then so you only end up getting your full advance a year after you sign your contract and you've given them all of the content and they've edited it. And always negotiate. I mean, so many people are just too excited to get their first contract that they sign it and send it. And there are always a few things that you can push back on. Get more free copies of your book. Get a step-up clause. That means if your book happens to be really successful, you sell more than, let's say, 10,000 copies, then have a clause that says that your percentage of royalties will increase in that scenario. Talk to someone who's been dealing with this. Make friends who used to be editors or that know the book contract world. You might want to get an agent. I didn't happen to do that, so I can't really speak to that experience. I did have a very positive experience hiring collaborators, interns, people that would be committed to work on the book with me and also set up a structure and set up pressures to which you have to address, you have to perform. That worked out quite well for me personally, and it applied deadlines and structure that were much needed. Yeah, and the power dynamic. This is quite fascinating. So you have to do all of this, pitching and relentlessly, yes, I'll show you more, editor. Here's what it could be. Here's what it could be, and you address all their concerns about: is there enough of an audience? Is there enough of is it the landscape not competitive enough? And then once you're signed, they have so much else to do that you're pretty much on your own. And if the book that you eventually deliver to them is 20 or 30% different than what they thought they were getting, they'll work with you, they'll edit it a little bit, but really it's up to you. And they just have to trust you. They don't have the time or the inclination to really have this kind of intensive back and forth that, let's say, I was expecting in the first book. So just a brief look at a timeline. It was a year of courting the commissioning editor, and then things moved pretty quickly after that. This is for the first edition. And then this is the distilled bits of advice. And definitely the intangibles, the last one is, I would say, the most important. I thank you for your attention, and I welcome questions that you might have.
We've got a microphone, so we can get our questions on the videotape as well.
Thank you, Will. That was like masterclass in publishing. Yeah.
Thank you so much for your presentation. It was really interesting. One of the points you made in one of your previous slides was kind of to beware of public perceptions of biodiversity. So my question might fall a little bit within that spectrum. But I'm interested in what the mechanisms are for ensuring that the burgeoning field of reimagining living organisms as biological factories for the future, how can we ensure that we don't repeat the same like ecological mistakes of the Industrial Revolution as we kind of embrace the biological revolution?
Sure, that's a good question, because if the systems stay as they are and the system, the rewards and incentive structure that we have is in place, then this bio stuff is just going to accelerate the dysfunction. You really need reform that prioritizes different things, that rewards different behaviors. How exactly to get there is a really tough question to answer. I think it's an array of policies. I think some of them have yet to be discovered and designed. Others are there and have been experimented with, and they're I think showing some positive effects, such as carbon taxes.
Maybe I should just clarify a little bit. I guess my concern is that when we think of like a single type of bacteria, right? You mentioned that we only know 2% of these. When we start kind of using the very little we know about the biological world in kind of on an industrial scale, this is again maybe unfounded here as a layman, but I'm very concerned about what it means when we start kind of putting out biological materials at scale, when we only understand maybe 2% of the living world.
I see what you mean. The unintended consequences will surely accompany all of this experimentation. There will be some negatives. I think my opinion of it is that it's unavoidable. I think what's important is that, and I think designers play maybe a positive and important role here in the fact that they're trained to be empathetic, they're trained to have certain considerations of their impact on the human and on the environment that will help guide them or help sort of correct for some of those potential mistakes.
Other questions?
To follow up on that, what happens with the mistakes? Today, you must know that some Chinese researcher has claimed that he has created designer babies. And if something goes wrong, what then? You mentioned cradle to cradle. What then?
Well, if you look at the kinds of technologies that we've already fully embraced that are producing measurable harm, coal-fired power plants, the number of deaths that you can attribute to that practice are very high, and what's being done about them. I think the situation is so bad that, not that it doesn't matter what the biological mishaps will be, but because we need such a leap in effectiveness and efficiency, that it's really sort of the only show in town that we have, or the only option I think that we have to greatly improve these things. So, sorry, that's sidestepping your question a little bit. Designer babies are, I think we're going to have to trust people to be responsible ethically when it comes to these things, and it's
they can be very responsible and still make mistakes.
right. But I mean, this has been the story with technologies forever.
Yeah, but they could bury their mistakes. In this case, a pandemic, it might bury us.
Well, it's always the case that technological progress outpaces social progress. Okay, were humans ready for nuclear weapons? Probably not. I mean, we already used them on each other. I think basically the cat is out of the bag, unfortunately, or fortunately.
Since writing this book, what have you changed your mind about, and how has that affected your daily or weekly practices? And secondly, because there's obviously a lot of great minds in this room, what do you need help with next?
So what's changed in my understanding of this topic, or what's evolved the most, is coming to the conclusion that, and it's very much the theme that was repeated in my talk, of having projects or promoting projects like that work with moss or snails or very unfrightening, non-human matter as a way to get people to be a little bit more comfortable with the whole endeavor, and also to pry there or push them to think creatively about working with biology. And then what's happening next? Well, there's the museum project, of course, but another kind of book project that I've been engaging with or what I'm working on, is to document the ways in which designers and artists are beginning to tinker with machine learning. And interestingly, there seems to be a thread between bioart, biodesign, and those practices, in the sense that when you work with, let's say, neural networks, interfaces, and systems and algorithms that are not completely well understood, and their outputs are not very predictable, you have to almost extend empathy to the machines and regard working with these things as almost a collaboration, that the AI systems have gone beyond mere tools or machines, and they're not human, of course, but they're something that can enhance or couple with your own creativity to make something entirely new.
So you mentioned the modern meadow and growing biofabricating leather. Do you foresee a future in which we'll all be wearing shirts with algae in them that change color, or have actual living organisms on our persons in some way?
I do. And I think, going back to the human microbiome, we already are wearing billions and trillions of these things. So, provided that these applications are superior to others that came before it in terms of their ecological impact or their ecological performance, I think we should go in that direction, and hopefully it's inevitable. I'm hoping that people will get over the concerns and fears that they might have around something like that.
I have a process question for you. And thank you for that whole section of your talk, which was great. So you raised this issue of breadth versus depth, and I think it's one that's really relevant for us here as our students work on their theses, and this line between becoming a expert temporarily on a topic and being objective and taking a journalistic point of view. So I'm interested in how you kind of, in working on these projects, see yourself. Is it as a journalist / documentarian, or as an advocate? How would you characterize your work?
As mainly a journalist, as a chronicler of this interesting development. Along the way, I've seen, because of the urgency of the problems that relate to it, that the advocacy part is part of my responsibility. So I try to do that as well. But I'm not a policy person. I'm not a politician. My skill set really, is situated in recording and writing about and understanding these things. So kind of more journalistic, I would say.
So take one more question.
Do you see population control or reduction as part of biodesign and solution to what you perceive as the problems facing the planet today?
I don't. I think that we're on a path, by way of access to reproductive health options, to have a stable population. I think it's going to level out at about 9 billion. But of course, that could happen faster if we're smarter about getting more access to reproductive health options to more people.
Because we are part of the biosphere, so to speak. As a part of that thinking, I would think that our own numbers contribute to the problem and potentially the solution.
You're right, they do. But it's also true that there's as much human biomass on Earth as there is ant mass on the Earth, and the ants are fine. We could have many more ants, and everything would be okay. They provide ecosystem services. They rotate the soil, and they help decompose all kinds of organic matter. And it's not necessary to stop their proliferation. So I'm hoping to become more like the ants.
Okay, so okay, one more question, last one.
Do you think commercial builders, do you think there is any difference between the concern of commercial builders as opposed to residential builders? And why would that be?
I think, generally speaking, there's not a meaningful difference. In talking to people, for example, who are behind the bioconcrete project, they have explained to me that in all their discussions with construction people that manage construction projects, that the golden rule is that it's just not allowed to cost more. Whatever you're building, if you have a new technology, if you have a new solution, like that's it. So if you can make the economic case, whether it's residential high-rise or a factory, I think it can work the same way. To expect I think, unfortunately, the construction industry is so conservative. They move very slowly in terms of adopting new techniques or technologies. They need a lot of data over a lot of time before they're convinced. So for instance, the bioconcrete, the testing of it was really only beginning in 2009, 2010. And so, we have examples of it going on for almost 10 years. But there's, the service life of concrete can be, up to something like 175 years. So it's the nature of the engineering of it makes it all happen very slowly.